Hi, it's Lisa Glase again with another lesson on equations. In the last lesson you learned to highlight pronumerals and add together like terms if they were on the same side of the equal sign, such as the equation below. The 6b and the negative 13b are both on the left-hand side of the equal sign. But what if they're not? What if the pronumerals are on opposite sides of the equal sign? This is what we're going to learn about today. In the equation 2a plus 6 is equal to 9 plus 5a, you start off pretty much like you did before. You would highlight the 2a and then also the plus 5a. But in this case, you have to somehow join them together. Can we just add them together? Will this work? Consider the following equation. Is it true that 5 plus 15 is equal to 2 plus 18? Yes, because 20 equals 20. However, if you wanted to join the 5 and the 2 up, can we just add them together? Does 7 plus 15 equal 18? No, it doesn't. So that's not possible. We cannot just join terms up by addition. However, what if we wanted to subtract the 2 from both sides? In that case, we'd have 3 plus 15 is equal to 18. And that's true and it works. In the same way, we can solve the equation 2a plus 6 is equal to 9 plus 5a by subtracting 2a from both sides. We start off in the same way. We highlight the pronumerals with the numbers and the signs. We look to see which is the smaller of the two, in this case 2a. So we subtract 2a from both sides of the equation. I put it right underneath the like term. 2a minus 2a would be 0, so they cancel out. Then we have a positive 6 is equal to 9 plus 3a. You can go ahead and highlight again if you'd like, but you should be able to notice the a is hanging out with the 3, so we must get rid of the 9. By subtracting 9 from both sides, we have 6 minus 9, which is a negative 3. The 9's cancel out, and we're left with 3a on the right-hand side. Because a is being multiplied by 3, we do the inverse operation, which is divide by 3. 3's cancel out, and we have negative 1 is equal to a. It solves the equation. Consider this one. We have 4b and negative 6b. Again highlighting the pronumerals. Noticing they're on opposite sides of the equal sign, we have to get rid of 1 and send it to the other side. I always choose the smaller of the two, which would be a negative 6b. The opposite procedure is adding 6b, so we're going to do the inverse operation, adding a 6b to both sides, placing the 6b underneath the 4b. They cancel out. We have 10b then. Minus 5, bring down the 5, is equal to 80. Again, if you'd like to, you can highlight the 10 and the b together, but it's not really necessary at this point. Since the b is hanging out with the 10, you're going to have to get rid of the 5 first. Since it's a minus 5, you're going to do the inverse operation, which is adding 5 to both sides. That gets rid of the 5. We're left with 10b on the left-hand side and 85 on the right. b is being multiplied by 10, so we're going to divide both sides by 10, and therefore b is equal to 8.5 or 8.5. On to the next equation. We have negative 2f and negative 4f. So again, we highlight the pronumerals, negative 2f and a negative 4f. Noticing they're on opposite sides of the equal sign, so we have to send one over to the other. Choosing the smaller of the two, the negative 4f, I would add a positive 4f to both sides. The inverse operation, adding 4f and placing it right underneath the negative 2f. That's equal to 2f, bring down the negative 5, equals, now in this case, negative 4f plus 4f actually equals 0, f, or just 0. Don't be afraid of the number, it's just a number 0. So f is hanging out with the 2, so we're going to get rid of a minus 5, adding 5 to both sides of the equal sign, subtract. 2f is equal to a positive 5. f is being multiplied by 2, so we're going to divide by 2, and f is equal to 2.5 or 2.5. It's a bit slanty there, and I do apologize for that. Now this equation's huge. We have a 3d, we have a positive 5d, and we have a positive 10d. My suggestion to you is this. In this sort of situation, add together like terms first on the left-hand side and on the right-hand side. So looking at left-hand side, we have a 3d plus 5d, that equals 8d. Then we have negative 20 minus 4, which is a negative 24. So we just simplify the left-hand side first. 8d minus 24 is equal to 100 plus 10d. Just bring that down. Then again, highlighting to show you that we have 8d on the left-hand side and 10d on the right-hand side. Getting rid of the smaller of the two, 8d, since it's a positive 8d, we subtract 8d from both sides to kill it off. Underneath the 10d, that gets rid of it, and we're left with a negative 24, not a positive 24, but a negative 24. And that equals 100 plus 2d. Again, the d is hanging out with the 2, so we're going to get rid of the 100 first. Subtracting 100 from both sides, we have negative 24 minus 100, which is a negative 124. The hundreds cancel out. That equals 2d. Because d is being multiplied by 2, we divide both sides by 2, and we have negative 62 is equal to d. Okay, your steps to success. Highlight the pronumerals with numbers. If they're on the same side, add, subtract like terms. If they're on opposite sides, get rid of the smaller term. See what the pronumeral is hanging out with, get rid of the other number, and isolate the pronumeral. That was fun. Thanks.